project. He's with us today. His name is Engineer Moatz Shawki, final year Cairo University. Please welcome Moatz.
Well, assalamu alaikum. My name is Moatz Shawki and I am a student in 4th year in computer department. I am very proud here to be in front of this gathering today, and I make my presentation at a very high level. I will not look out to details a lot. This is my agenda. Take a look at it, and I will begin now. Okay, here is the project specification that you will require to make the contest. It is a very simple key remote control, just to accept the data from digital input from keypad and transmit it wireless to the receiver which accepted and check the code is correct. Then open the lock. Else you can play alarm or something depending on the state in it. I will begin first part is the keypad. We have it. These are like a matrix. When I press one, it short circuit between the first row and first column. Then I know it is one. So when I detect it, I just choose the row is one with logic one, and then detect the column. If it is one, then yes. Else I go to the other column like a for loop. Here is the algorithm I follow. This is a famous one. The main problem here may be in the key load balancing. I will see it here. This part is supposed to be, I transit from logic 1 to logic 0, but it doesn't happen like that sharply. We have here some kind of transition from 1 and 0. This is called bouncing. You know, bouncing in English means the ball, you hear it in football, like when the ball hits the bar and bounce. It bounces from the bar. So I don't want to hear, because it will give me wrong classification to the 1 and 0. So I want to eliminate this bar. Maybe I go into delay state to get rid of it. Here's the threshold. I use the FPGA, and its threshold is just 3.5 volt. So all this point here, this point will be, if I go to this state, it will know that I am 1, and there go to down to 0 again, which will give me a wrong classification. Here is the simulation I followed. We can just look at this bar. Here start the debouncing. Here I just follow the one step. I'm sure it's not clear because it is very complex as a view, but I just want to say that this debounce problem is the main problem in the keypad. There is two solutions. There is a book called Art of Electronics. Has a complete shortcut in getting rid of this debouncing problem. It just used some kind of capacitor. You know, capacitor has a threshold value and then it recharges again. He take advantage of this feature and get rid of this debouncing. But I use a software solution like a delay. There is a simple algorithm. If no push button, they stay in the first step. If then yes, I go to the next step. I hold again like if I press and if I release. Okay. If I press, then I go to another step, and when I release, I go to the third step, which is the final here. The most important thing in delay is that I just take the delay. I made it by trial and error to just fill in this delay, no more else. Because if I just go to this delay period, I can make a transition from 1 again and 0, like here. I'm here going again to 1, but I didn't feel it because my delay is big. So I just have to make delay like this one, just to be very